Hey everyone, good afternoon. Thanks for having us. So I'm here with David Hassoun, Chief Technologist on the Cloud Media Solutions team. I'm Tobias Heinl. I'm the product manager for the client ecosystem. Small disclaimer, just before we get started, if you heard about Dolby I/O, that's not us, okay? If you want to buy speakers, also not us. Although, if you operate a cinema, we might be able to work out something for you, but talk to us afterwards. All right, awesome. Let's get started. The next frontier of streaming performance, what is that about? And why are we here? I mean, that's an important question to answer. As a company, we're really passionate about content. We're passionate about creating the best media experience in the world. We're passionate about bringing things to life, right? We're all, at some point, we're all connecting with the things we're seeing and hearing and the goosebumps that induces. So, as Dolby, we have a ton of content out there. We work with content creators, the film studios in Hollywood. And there's a ton of devices, you'll see that tiny EE logo on. There's a small issue though, right? In between of those is a big gap, and that is content delivery. And so far, it's really something that we haven't been involved in very much. But the issue is if you want to create an amazing experience, the way how you deliver that content and how effectively you are able to deliver that content has a huge impact, right? Right now, we're all the way on the right side of the picture, right? That's where the science of sight and sound really is happening, where you see and you hear and you feel. But of course, others have touched on this. Actually, getting this experience across can be challenging. And the quality of service upstream on the delivery will, to some degree, become a gating factor for the quality of experience that you can deliver. So where would you want to go? And again, others have touched on this, right? Whether you do actually operate live TV or not, where you want to be is have an experience that is uninterrupted, right there, and has consistent quality, right? And you want to be able to do that on a huge number of different endpoints, operating systems, apps, so that ultimately you get to a point of having 99.999% reliability. Now, of course, we know that's not always the case, and so I'd hand over to David here, who can explain you some of the challenges that you can run into.
Hey, you, Toby. Okay, so we know the goal. But what's the challenge in this right now? And the reality is we're just not there yet. When we look at the quality of experience that users get today, it's not perfect. We want it to be, right? Here's a bit of information. It's a little bit dated from Conviva. They haven't released the 23 numbers. And this is actually probably on the good side of really what they expose. And even when you see some of the stuff, so for instance, like average start time, you have to consider if you get an overall average of 4 seconds, you might have a good chunk of people who are getting into that 2-second mark, which is where we really want to be. But that also means you have a lot of users that can be all the way up to 8, 10-second users, well over 4. And 4 is a good marker for we might be annoying these users, and this can lead to churn and other bad things that can happen. And that's just one of the factors, right? Buffering, quality, these are all things that we run into and in different ways. So there's a gap that we have to work towards addressing. So at Dolby, we love doing research, and we have an amazing advanced technology group. They did this great little bit of study when we got some feedback from actually a major broadcaster in the States that they saw a lot of issues at the CDN level, that they came and went really fast, but they had impact to their users. So we did this test. We did this for about 40 days. We ran 30 emulated streams running 24/7, loading segment after segment. It was about a few hour total duration, and we just loop it. And did that 24/7s over 30 different locations, every zone and range we could get with AWS in the US, hitting 3 of the major CDNs consistently. And wanted to see what the results look like. Now, the guys at Dolby's love this. They're like, hey, this looks like noise for networks. Like, we're good with noise and audio. We can probably solve this, right? So what we saw was that there's a lot of issues that happen over time. Here's a zoom in on actually just a few days. It's about 3 days worth of time. 3 different CDNs. We've anonymized them. And the vertical is the time to the first byte delay. So we had sometimes going up over 5 seconds just to first byte. And a lot of them that kind of hit into that 1 to 3 second realm. One CDN was misbehaving quite a bit. And all of them had some challenges at one point, which later on we're going to come back to this. So this was a good example showing like, hey, there's things that happen that can delay. The dots indicate actually failures, right? It could not respond or would not. What we also saw, though, when we took a step back, is different locations, different things. Also certain CDNs, different things. This was one of the CDNs. This was really interesting. Every Monday, they either had a major release or a support window, whatnot, that they were doing updates, that there was a consistent degradation at the same time, all right, when it came to the performance. And that was something that wasn't really expected, and they didn't know what was going on when we talked to them either. And then when we looked completely, taking a step back on this is all the locations. These are failures, right? So this is when they had a 400 or 500, and also how long the failure lasts. So going all the way up to 90 seconds, and a lot of them being anywhere from the 10 to 50 seconds. These have the ability to impact your streams. And what this really kind of came down to is bad things happen. We don't know when they're going to happen. We don't know how long they're going to last for. And this does have an impact at individual CDNs. And they all perform a little bit differently at different times, right? So now we need to look to how do we start framing a solution around this, right? Starting at this, we look at like how media coding works today. Historically, there was this whole concept that's very linear, right? We have our media. We create our content and we deliver it out in pretty straightforward routes, whether it be cable, over the air, or, of course, physical media. Now, when we look to the streaming media side, right, this is an example of a single CDN where there's a network, and it can have different paths through that network, but once it kind of establishes that path, it sticks on that path. We have a single chunk of content and a single point that we need to get to, and it will traverse that. But the question is this really the most effective way, right? Now, one of the things we can look to do to improve this is we can integrate multiple path options, right? So we have a multi-CDN solution. But with this, it's still going to be determining a single path across whichever CDN that we want to tell it to. So it can be from CDN 1, or CDN 3, or CDN 2. Either way, once we establish what that is, it will deliver that segment over that path. Now, there are more complex solutions. So you could try to do single source multipath, where we try to start loading in content from different paths to then recreate it back. This is an example of what happens one link fails, and then you have to re-request it, and that delays that. Especially if you're loading the file, you have to go from front to back to be able to start decoding it and be able to use that. Now, this is just a single rough example. There are other ways that this can work and benefits, but there are core limitations of trying to do this today with how things work. So what this means is that we're ultimately left to either stale information as to choose what solution, what path to take. That might not be valid anymore because it changes so rapidly. And also factors, whereas we end up suffering down to the lowest common denominator. Whichever, if you're trying to do a single path or a multi-path with a traditional, you can then get stuck at the lowest common denominator. You can have diversity for resiliency, but you lose out in other ways. Now, one of the things that's important is we don't always want to come up with something crazy and new just because every time and to throw out what we've done. As you guys heard about before, like one very different approach for streaming right now that has different use cases is like the WebRTC stuff, right? So Dolby acquired Millicast, has a great solution for going on that ultra low latency WebRTC base, and they can do it at a decent scale. But when you start talking about some of the stuff we were talking about earlier, like Cricket, or these other major events that we're talking millions and millions of users, WebRTC probably isn't the best solution. It doesn't mean it can't be used, but there are better ones. And the current infrastructure, the way we do things today with HLS and Dash, segment-based delivery, it works very well in those scenarios of scale, management, and reliability. But there's still gaps there. So instead of recreating the wheel, we wanted to look to what can be done to leverage the current infrastructure that's truly used and trusted today, but to truly use it to its fullest extent and take out everything we can of that, right? So this is a solution that we've been working on and doing a lot of research for a while, and also going to lead towards what we'll talk about in a little bit, also around some standards. So multi-source coding. Now, if anyone's here familiar with network coding, this stuff might start to look really familiar. But the idea is that we can take this original data, so this will be our video segment. We're going to apply on some lossless coding. Now, this is not video level encoding. It has nothing to do with the bit stream, right? This is just any file. We could do a transform on it of sorts and create 3 unique representations, right? So these are 3 unique orthogonal representations of that original media. Has nothing to do with video encoding, nothing to do with DRM, doesn't matter if it is, doesn't matter what it is. This is just going to be creating a transformer of a representation of that. And each segment can be used independently, in part or in a combination of the other ones, and we're going to see how that works. So the concept is this: now that we have these 3 representations, we can now deliver out this content. We just need to get, in this kind of example, 9 blocks of any of the combinations that we want, and then with that, that's the total file size we need, we can decode that back into the original segment. Now, one thing that's also important to note is that this works also with anything that's addressable to load media from. So you can do this with peer connections as well. You could do this with open caching and directing stuff directly from ISPs, and a number of other solutions as well. So it's really extensible, and it can be a combination of that. Now, just to kind of hammer this home a little bit, the idea is, oopsie, right? We start with our original data. We're going to break this up into 3 chunks. This is just to give you an example at a very high simplified level of what's really kind of happening here and how this works. We're going to break this up into kind of 3 kind of symbols or chunks, X, Y, and Z. And then now we can then create different variations of those in our old school algebra. So we have X, Y, Z, X, 3Y, 4Z, and different variations of those to create extrapolated versions of that. And then with those, if we take any 3 from any of that list in the second column, we can then solve back for X, Y, and Z. Right? And that's the basics of how this works at a very simplified level. Nice thing is this is all linear-based stuff, so it's very, very fast when it comes to encoding and decoding. And what we get in the result is we're able to load from multiple CDNs simultaneously. It doesn't matter what order data comes in. As we get enough data, we can start decoding right from the beginning of the file out. It doesn't matter if it's from CDN 1, CDN 2, whether it's chunk 1, 7, 3, 2, doesn't matter. We just need enough data, and we're able to achieve that. So the ultimate total file size is still pretty much the same, as well as ultimately the egress. And what we end up with now is the idea of self-optimizing players. They're able to load from multiple CDNs and get data from different locations at different time, at that moment, getting the data that's best delivered to them. We do this with doing byte range chunks that also change size as we're loading them based off of what we see as the throughput going on from the CDNs. And we do that also to avoid having to do much overload. And it becomes a really powerful solution. Now, if we go back to this wonderful network noise, right? If you look over in kind of this middle range over here, you're going to see that 3 CDNs actually had a not great performance at that time. It's kind of in the middle there. Now, that's kind of uncommon that all 3 CDNs won't have a great performance at that time, or that could be indicative of maybe you're having an ISP issue or something for that region. In this case, it didn't really apply as much. But when we actually applied this solution and tested this, so at the same time we did this whole test, we were actually running this other test as well. This is what it looked like when you used all 3 CDNs simultaneously with this multi-path, multi-part. So we went from noisy, denoised, from a pure network and delivery standpoint. And that creates some pretty good value in what we see in the end result of the experience. So from this research that Dolby's been working on for a while, the big goal was to kind of create some industry standards around this. There's currently an industry standard called the Coded Multi-Source Media Format, CMMF, not CMAF. We love to have things that are really close, so it's nice and confusing, keep everyone on their toes. But this is ultimately to kind of describe the bit stream and the transport layer of how you can leverage this coded data within this media standpoint. We've been working with STSWE. It's already gone through the draft stuff and so forth, and is progressing really well. And other key companies are supporting this. And it does support other different coded formats out there right now as well. And just to kind of give you a bit of clarity, how and where the CMMF is applied, right? So here's our example before. It's going to be defining within the encoding side the data that's then going through, and then, of course, decoded. So I'm going to turn this back over to Toby to talk about how we've also looked at applying all this to make sure that this really works.
All right, thank you. All right, so as David said, we actually have a productized version of CMMF right now. That is called Dolby XCD. and XCD stands for Experience, Coding, and Delivery. What it does is, by leveraging the combined power of the CDNs, you improve the quality by aggregating those resources in the network. And then, because we resolve that bottleneck at the top of the chain and improve quality of service, you can benefit from quality of experience improvements down the line. What it also does is, of course, in the event that they do experience any kind of failure, you can transition over to other network resources much more seamlessly than conventionally possible. The other thing is, because we are now involved in the handling of network requests, we get some pretty deep insights on performance that we can leverage to improve decisioning in the future. Integration-wise, this is a very lightweight concept, right? As David said, really think about this more as a container. Again, some lightweight coding, not nearly the complexity level of a video or audio codec. We have a just-in-time encoder that we hook up to the origin, right? So when content is requested from the CDN and there isn't a version available that has already been encoded into XCD, it will hit that encoder, it will create an asset on the origin, and it will cache it in the CDN. That encoder is deployed directly inside of the customer's environment, so we don't have to shuffle the data far throughout the network. And then the client side of it, so we do have a tiny component that we hook up to the media player inside of the streaming app that then decodes the data and handles a bunch of other things that I want to talk about. Since I'm here and I'm the client ecosystem product manager, I want to talk a bit about what that client implementation looks like. So this is a multi-platform SDK solution, right? We provide a native SDK for every platform. Today we have Android, we have Apple, we're building web and other platforms as well. Just explaining roughly what some of the high-level components are doing. So most obviously you have the XCD decoder, right? So you put XCD in, you get regular -HLS segments out, right? The ones you know. We also have a component called flow control, and that mechanism essentially steers how much we're drawing from one particular CDN on a given client at a particular moment in time, and we're adapting that. And we're doing it in a way that we're making sure that we're obviously not drawing 3 times the amount, but we're very purposeful and lean on how much data we're consuming. Finally, it turns out, the internet and clients and players, they're not used to multi-source, multi-path delivery. And so what that also means is if you feed something to a player that has been transmitted this way, they might get confused, right? They might get irritated because suddenly you're turning up the faucet, there's so much data, then there could be a gap. And so you need to adjust the ABR behavior. And that can be specific to the ecosystem you're operating in. Finally, we do gather a whole bunch of metrics, both network metrics for quality of service as well as traditional quality of experience metrics, and you can feed them to Grafana or Conviva, any other solution you like. Then, because this is inherently a client-based solution, you need to shield yourselves from dependencies, right? I think Exoplayer, you're looking at roughly 4 to 8 updates every year. You might have to update your SDK, and of course, you're trying to abstract that from the customer as well as from yourself, because you need to be mindful of that dependency. So we have an extra abstraction layer, and we have a plugin architecture that essentially separates our core functions from the operating system and also from dependencies to the media player, so that any kind of API changes in between become very lightweight changes that we can handle without breaking an existing integration for a customer. Now, the cool part is we are actually, right now, as I'm standing here, there's probably people somewhere in the world that are experiencing this and they don't even know. We have a real-world trial with our partner CuriosityStream that today has already delivered way more than 1 million hours of delivery. We've started that on Android. We have actually since expanded that to Apple devices, iPhones, iPads, Apple TVs. And yeah, we're seeing some pretty impressive benefits. So I don't want to go through all of these, but you can see, different device categories. We're having some significant impact on things like startup time, the maximum bitrate that a client can reach, connection-induced rebuffering ratio, and the occurrence of rebuffering events. You can also see that certain things are more pronounced. So for example, we're having pretty strong impact on startup time and bitrate on mobile cellular connections, and that could just be an indication of, for example, bottleneck between the cellular peering points and the CDN infrastructure. Of course, these are average numbers, and what that means also is that, at a certain point you can't push more. The bitrate ladder has an end. But what we're really doing is to pull up from the bottom, right? The users that are most at risk to experience a quality issue or to potentially churn, and cancel the subscription. We're really taking them and leaving them up to a higher level of quality here. So as you can see here, for example, this is a plot for startup time. And with traditional CDN, you can see this 29%. We're really bringing that down significantly. So ideally, where we want to be is that 90% or greater experience a startup time of 3 seconds or less. And so you're really trying to keep everyone under that critical step before it becomes painful for users and ultimately, of course, also for the service. All right. That's all we have. We thank you very much for bearing with us until the end. And yeah, we'd love to talk to you about this if you're interested. And wish you all a very nice day. Bye.